Hello, class. I hope you're all doing well, staying safe, practicing social distancing, and washing your hands. So this is our sixth math video. We're going to be reviewing again bar graphs. It's just extra practice. So our objectives, we can create a scaled bar graph. So when we get information like this in the bar graph, we're usually going to get this right here, like the data, right? Like the data with maybe for this example, maybe students and magazines sold, but it could be anything. It could be like favorite color, amount of the attendance of the school, the most money raised by different schools for a fundraiser. It could be any data, and you're gonna get it presented like this. For this, we look at the numbers. We notice that we're not dealing with up to like 30 or 40. We're going all the way up to 600. So the data is getting pretty big. So A, use a chart to draw a bar graph below, create an appropriate scale for the graph. So noticing here we go up to 600 and our lowest value is 100. So we know that it wouldn't right here we're limited with the space up to here. But so, let's say you had an infinite amount of paper and you could just do your graph as big as you wanted to, and you count it by here on the side. You count it by 1, 2. I don't know if you can see it. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You went indefinitely up. It wouldn't be effective. It will take you forever to do that, and it'll be a waste of time. So that's why we scale it. So sometimes it's appropriate to skip count by 10s, 20s, depending on how big your data is. So if we look here, we know we have to go all the way to 600. So we need to factor that in. And we need to make it small enough, so 100. So you have to really think about like what scale you want to use. So appropriately, it would be 100 would be okay. So 100, 200, 300, 400, 500, 600. So I could go up to 600. And yeah, you look here at your data, you say, well, you're going to have 250 for one of your data points. 250, okay. So I know that if this is 200 here and 300, so there's a difference of 100, right? Half of 100 is 50. So I know that my plot would have to be eyeballing it somewhere here at halfway mark to mean 50, to mean half of 100, 250. So now I can go ahead and plot my data. So I know my students, my x-axis is my students, so my student names will go here in the x-axis on the bottom part. So I have Ben, I'll put a B for Ben, Rachel, Jeff, Stanley, and Debbie. When I look at Ben, I look at my y-axis, my scale, my appropriate scale, and it means our magazine sold. So Ben sold 300 magazines. So I go here to my scale, 100, 200, 300. I eyeball it to get to hover above Ben's name, and then I go ahead and do my graph, 300, my bar graph, 300. Now I move on to Rachel. She is 250. So I go to my scale here on the side where my numbers are at. I eyeball it. I know it's 250. I'm just doing dot, 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 dot. But you shouldn't do that. I'm just doing it to show you. But you just eyeball it. You follow along carefully with your finger to try to get as close to the halfway, where the 250 would be. I mean, I could write it. It wouldn't harm me to write it. But then it gets kind of messy. And it's not really that difficult for somebody else to come in and kind of figure out that means 250. Jeff is 100, so by my 100, I eyeball it. It's easier when you have the paper in front of you because then you can just put your finger and then write it. Well, not so easy with me with a computer, especially because I'm using a mouse to write. So it's kind of yeah, that's 100. We're gonna pretend it's 100. Stanley's 450, so I'll find the 400. 450. So my 450. I'll draw my graph there, and then Debbie 600, our star seller. 600. So just quick visual. Even though I just came across this graph and I haven't taken the time to really interpret it. I say, okay, those are magazines sold. Those are students. Oh wow, look at this girl Debbie. She sold like a lot. We know that Jeff and Rachel and Ben, they might need a little help. They could probably work together, or maybe they could buddy up with Debbie to learn some of her strategies, techniques. So that's like some things like as a manager looking at the data would do, or if you look at the sales, oh, what magazine was uh, Debbie selling? What magazine was she selling? Was it Time? Was it Science? A fashion magazine, or different? So that's why bar graphs are very important in the real world. So once I have my bar graph, I go ahead and start answering questions pertaining to my bar graph. So if I look here, B, explain why you chose the scale of the graph. So in complete sentences, I would explain why I chose this. Like, I chose the scale of skip counting by 100s because it allowed me to plot all my data set, all of my information, and still and factor in the smallest and the largest number. Because if I were to be putting it, and it was the most efficient scale for me to use. Again, because if you skip counted by ones, by a unit of one or a unit of two, 1, 2, 3, 4, 5, 6, 7, I would tell you, nope, that's not appropriate for this data here because the data's really high. It goes up to 600, and you're dealing with. I mean, if you were talking like Debbie sold maybe 10 magazines, and the lowest was Jeff. He sold 2 magazines. Then appropriate scale would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But for these numbers, an appropriate scale will be something larger. How many fewer magazines did Debbie sell than Ben and Stanley combined? There's a multi-step question, so I have to read it twice. How many fewer magazines did Debbie sell than Ben and Stanley combined? So I know I'm combining Ben and Stanley, and then I'm figuring out how many fewer magazines Debbie sold. So that means then I have to subtract. So first I add Ben and Stanley. Ben is 300. Stanley is 450. I'm combining 0, 50, 700, 750. 750 is what they sold combined. Take away Debbie's, which is 600. And we know we're left with 150. So in a complete sentence, I would write, Debbie sold 150 fewer magazines than Ben and Stanley, because that would be a complete sentence. Complete sentence. So now there's like a little bar here. So you might not be able to see it, but I can see it, so I can't write here. So I'm just going to write it over here on the side. But remember, it pertains to D. You know what? I'll change the color too, so that makes it easier to identify. I would use blue. So D. How many more magazines did Debbie and Jeff sell than Ben and Rachel? Okay, so it's asking me to do a couple things, so I'm going to read it again. How many more magazines did Debbie and Jeff, so I'm combining Debbie and Jeff, sell than Ben and Rachel? Okay, so I'm going to add Debbie and Jeff, I'm going to add Ben and Rachel, then I'm going to subtract to see how many more magazines. Debbie is 600. Jeff is 100. I'm going to add it, so it's 700. And then I'm going to add Ben and Rachel. Ben is 300. Rachel is 250. So that is 550. That's an ugly 5. 550. So I have my Debbie, Jeff, and I have Ben and Rachel. Now I'm going to take away to see how many more they sold. So 700 take away 550. I'm going to use a different color. I will use magenta. So 0 take away 0 is 0. 0 take away 5. I cannot do that. What does the 0 have to do? It needs to borrow from its neighbor. Hey, it's 7. Can I borrow one of your hundreds? Yes, you can. So the 700 becomes a 600. The 0 becomes a 10. Or a 100, but a 10. 10 take away 5 is 5. 6 take away 5. 600 take away 500. 600 take away 500 is 100. So my answer is 150. So here in a complete sentence, I would write, Debbie and Jeff sold 150 more magazines than Ben and Rachel. So easy peasy lemon squeezy. Just make sure you're answering complete sentences. So this is what you are going to turn into me. So if we read here, Maria counts the coins in her piggy bank and records the results in the tally chart below. Use the tally marks to find the total number of each coin. Okay, so remember, we have our tallies here. When we're gathering data, when we're counting, it's good to use tally marks because you do what's called a little bundle. When you get 5, you just bundle it up 1, 2, 3, 4, dash across, and it counts as 5. So that when you go back and add up your data, you count by 5s: 5, 10, 50, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 66, 67, 68. So this has 68 pennies. So that's how you go about counting. Remember, if it's not a bundle, it counts as only 1. So 5, 5, 5, 5. Once you get to the little sticks by themselves, you count them as 1. You add it to what you had already. So let's say, I don't know what's here, but let's say it's 50. So it would be 50, 55, 56, 57. It's not that. I'm just giving you an example. So make sure you're counting. You have pennies, nickels, dimes, and quarters. So letter A, use the tally chart to complete the bar graph below. The scale is given. Ooh, so they gave you the scale for this one. So you know you're going to be counting by tens. 0, 10, 20, 30, 40, 50, 60, 70, whatever. And then you're going to plot this data. After you plot it, you're going to answer the questions pertaining to this. Let me see. How many more pennies are there than dimes? Maria donates 10 of each type of coin to charity. How many total coins does she have left? Show your work. All right, so make sure I don't know, there's a D there. Again, there's no bar there on my side of the screen, so I don't know what this was, if there's a letter D there. So when you complete this, answer the questions in complete sentences. I'm trying to see, complete sentences. And turn it in through Seesaw. All right, you guys, stay safe. And stay safe and practice social distancing and wash your hands.